morning, students. This is the class of heat transfer, and in the previous class we have studied what is heat transfer, what are the types of heat transfer, and what is heat conduction, some basic examples of heat conduction, and the Fourier's law, and these basic things we have studied. So this is the important class today, where we will study the three-dimensional equation of heat conduction. So we will study how to derive the three-dimensional equation for heat conduction. So before going to the topic, we should know what is three dimension. Let us assume in the space there are three axes which are perpendicular to each other. Two horizontal axes, one vertical axis. The two horizontal axes are x-axis and z-axis. The vertical one is y-axis. So in this topic, we will take a cubic object. So we have to know all the faces. So x-axis means this one is the x-axis. So this is also called x direction. In 3D surface, we have to keep in memory two things. One is direction, another is plane. So if you will see in direction, there are three directions: x direction, y direction, z direction. Similarly, plane also x plane, y plane, and z plane. The direction in planes are perpendicular to each other. X plane is perpendicular to x direction. How? This is the x direction or x axis. The plane x plane is in between y and z. This is the x plane. Similarly, y and z also. Y and z plane are also available. So this plane is called x plane, which is perpendicular to the x axis. Similarly, in y direction, the plane is in between x axis and z axis. Similarly, for z axis, it is in between x and y. So we will next draw a cubic surface where we can better understand the planes and ellipses. This is a cubic which has 6 faces. Here the x-axis is BH or AE or BA or CG. So the plane related to x is AB, CB. Similarly, this one is y-axis. So the plane related to y-axis is CDGH, ABA. Similarly for z-axis, this one is the z-axis. The planes is ADEH and BCGF. Next, we will see what is heat conduction. Heat conduction is the rate. It is the process of heat transfer where heat flows in a metal bar from one side to another side. So let us assume this one is a metal bar where heat transfer takes place from this side to this side. So we will take a piece of metal from the bar. From where we will derive the equation. So the dimension of this piece is dx in x direction, dy in y direction, and dz z direction. So in this cubic, the width are dx, dy and dz. So here how you can see the heat is flows from left to right. Here also this is the heat input and this is the heat output. As it is flows in the x direction, let us consider first in one direction. We will now consider in x direction only. So the heat supply to the bar in x axis is Qx. The amount of heat transferred to the bar is Qx. So it entered to the x plane ABCD. Then it travels dx dimension, then it comes outwards. So the amount of heat came out after the bar is Qx plus dx. Except the heat supply, the cubic had some inner heat generation power, which is Qg. It is called heat generated inside the object. So now we will calculate Qx minus Qx plus dx. This is the amount of heat supplied and this is the output of heat. So from the Fourier's law, we know the value of Qx. It is minus Ka into dt by dt. So when we are considering in the x direction, the dimension of x plane is dy into dz. So the area is dy into dz. So come to this point. What is the meaning of Qx plus dx? It is Qx plus derivative of Qx with respect to x direction, as we are considering in x direction. So when we will simplify this one, so here both the Qx is cancelled. Now we will put the value of Qx from this here. Now this both the minus are cancelled. As we are considering x axis, so the k is ax. It is a constant thermal conductivity, so it will come to the front. This one is the value for only x axis. Similarly for y axis, it is ay into d square t by dy square into dx. Similarly for z axis, it is kz d square t by dz square into dx into dy the net rate of heat transfer is addition of rate of heat transfer in the all three directions, which is qx plus qy plus qz. That is addition of this one and this one. Here dx dy dz is common. So we will bring that one outside. According to the first law of thermodynamics, we will derive the equation. So according to the first law of thermodynamics, the rate of heat transfer in the object, which is the net heat transfer qx minus qx plus dx plus amount of heat generated inside the body, in the body or object. This is nothing but qx minus qx plus dx. This one is qg equal to change in enthalpy which is rho h plus work done. But here we will ignore the work done because very negligible what is done here. So dou h is equal to dh by dt. Again, what is the dh by dt? Change in enthalpy is equal to the mass into specific heat mass is, the formula for mass is rho into E into 60. So we will put all the values of change in enthalpy, Qg and this in this equation and find out the final formula. So what is Qg? Qg is the amount of heat generated in the body, which is equal to the amount of heat flux in the body into volume of the body. So here volume is dx into dy into dz. Okay, now we will put all the values at one place. So what is the value of qx minus qx plus dx? This one. As we know, kx is thermal conductivity and is always same for all. That is k equal to kx equal to ky equal to kz. So we can also take out this as a common k into d square dy dx square plus d square dy dy square plus d square dy dz square into dx dy dz plus amount of heat generated inside the object, which is this one, Qg into dx dy dz equal to change in enthalpy, which value is this one. And the work done is avoided. So again here we can put this as common. The value is dx into dy into dz. So these both the terms can be cancelled. If you will divide with k in both sides, Here rho Cp by K, it looks like which one? Thermal diffusivity alpha equal to K by rho Cp. So it is the inverse of that one. 1 by alpha equal to rho Cp by K. So here we can put the value of 1 by alpha. This is our final equation, which is called three-dimension equation of heat conduction. This is known as three-dimension equation of heat conduction. Now, here what are the components? This is the heat generated inside the body. Okay. This is the change in temperature with respect to time. And another, these are the three values in three directions. So there are few cases will come in the equation. Sometimes it will ask different cases. Like in one case, it will ask the amount of heat generated inside the body is 0. In that time, we have to neglect this term. Similarly, sometimes it will ask the thermal, the change in temperature with respect to time is 0. Or sometimes it will ask show the equation in one dimension. So that time we have to neglect these equations. Sometimes it will ask show the equation in two axes or 2D equation. So that time we have to show in x and y. We have to neglect the z term. Okay. So this is the derivation of three-dimensional equation. Okay, thank you.